Welcome to our GitLab Credential Lifecycle Management demo video. We're going to talk about the problems with today's GitLab Lifecycle Management, and then we're going to also show you an end user demo and talk about how it gets configured on the Aembit side. So GitLab doesn't actually do lifecycle management for workloads. They do have it for user accounts. You can create a just-in-time user account using something like SAML or OIDC, but they really don't do anything like that for workload accounts. What typically happens is an admin will go in and create a service account and then create a personal access token or PAT. And then they have to copy that somewhere so that developers can use it. With lifecycle management for workloads, we take care of a lot of these problems. So what problems are we solving? First, we're reducing the secrets proliferation. In most cases, you'll have long-lived API keys, and you'll have a bunch of other variables that are used in your GitLab environment to store these keys. The second problem is that these keys are manually created and rotated. This is error-prone, time-consuming, and most of the time people just forget about these. So they'll leave the system exposed because somebody will use the credential in a way that it's really not supposed to be used. They might forget that these keys even exist in their code. There's also a lack of granular control. Somebody might make a service account that has access to every project, scope, and so on. Next, there might be fragmented secret storage. Somebody might create a key and then store it in a GitLab variable. It might be a developer that goes and creates a key and then throws it on their machine. Or it might be in some external vault. So there's inconsistency and a lack of single source of truth when it comes to the storage of these secrets. There's also limited auditability. Trying to figure out who is using which secret, when they are using it, and why they are using it. It is very challenging when the secrets are just everywhere. Lastly, there's also the complexity of federation. You may create an application or a CI/CD workflow that's talking to different SaaS services. These might be services that are in AWS, Azure, and GCP. Trying to make sure that everything can talk to each other requires a bunch of unnecessary code in your application. If the authentication can be injected automatically, it reduces some of the work that your DevOps and devs are doing today to not only create the federation, but also use it. Fetching credentials is just work that doesn't really need to be done if you're using a solution like Aembit. With that introduction, let's get hands-on with Aembit. All right, now let's look at the demo from the end user's perspective. So here you see I want to make a call to the on-prem GitLab deployment that I have. I want to get all the users that are configured, and I'm using this JSON parser to display it in a nice readable fashion. I'm running this from a system running in Kubernetes, and this globex portal suffix will be important when I show you the policy. So I'm going to go ahead and run this. And as you can see, it's returned back all of the GitLab users. One of the things you'll notice that's super important is I made the call without putting any credentials for authentication. So those will be injected, and the latest and greatest credentials will be injected. We're going to now switch over to the Aembit admin portal to see how this is done. Okay, let's look at the access policy that I'm using to make the call that I just made. So the first thing we define is the Kubernetes pod. Here is that globex portal. So we define a way to identify the portal. But we don't just trust that, because those things can be, like a portal name can be reused, a host name can be reused. So there's another concept called trust provider. So what the trust provider does is it actually talks to my Kubernetes cluster to get things like Kubernetes namespaces and so on. So I can compare what the system is telling me to what it actually is. And that's how we can trust the identity of the client. The next part of my access policy is the server workload itself. And here is where we define things like host name, the ports and protocols and so on that we're using. And then we also let it know how we're going to do authentication. So we're going to do HTTP authentication using a bearer token. I also have access conditions configured. So along with verifying the identity, we want to make sure that the system that's making the call is based out of California and the calls are being made during business hours. We can also configure things like checking with Wiz or CrowdStrike if I'm trying to check the compliance of the system. And then lastly, the part that's probably the most important for this new feature in this demo is how do we get the credentials and what do we do with the credentials? And here you can see there's a credential provider. There's a new type called Managed GitLab Account. And to show the Credential Lifecycle Management feature for GitLab, I'm going to go to Credential Providers and then Integrations. So here I have a GitLab service account that gets configured. So I point my configuration to my on-prem system. I have a service account that I've already configured. I generate a personal access token and I drop it here. As soon as we drop that personal access token here, Aembit goes and rotates it right away. So that whatever service account we're using, whatever PAT I got, I can't reuse it because right away we automatically and systematically go and rotate it. So if I did save it somewhere, I copied and pasted, it's no longer valid. So we rotate the admin service account that gets used immediately so that nobody has it. Okay, once we define the configuration, then we go and create a managed GitLab account credential provider. And here we point to the GitLab integration we have. We give it a service account username. We give it things like the group IDs that it can function for, the project IDs. So it will be least privilege access, and you can define exactly what internal group project and so on you have access to. And then we also can put in what kind of access it has, in this case maintainer, and then as well as the API types. And in terms of rotation time, the minimum rotation time allowed by GitLab is 24 hours, so 1 day. And that's what we recommend. Let this thing rotate as fast as it can. Since it's all done behind the scenes automatically, you shouldn't worry about, oh, I have to do manual rotations. Let us do it. And then as soon as we get the new token, we will inject it into the policy if everything else in the policy is matched. And here you can see that it gives you token last operation time, token expiration times, and so on. So I did run the command a little while ago. Now let's go look at reporting. Reporting here, you can see that it ran from my Kubernetes workload. It used the GitLab engineering hosted server workload. If I go through everything, you can see that I identified the client workload. I identified the server workload. I looked at my access policies. I looked at the access conditions. Both of them were verified. I attested the identity of the system using my trust provider. And then at the end, I retrieved my latest token and I injected it. So from the developer's perspective, they never have to worry about any of this stuff. We do it automatically using the most secure means necessary. When we rotate the credential, we go and we grab the latest token, we inject it so that all of the rotation and creation of the account, everything gets automatically done. And if I go into credential provider and I delete this credential provider, it'll delete it also on the GitLab side. So I can have an active integration, but I can also delete this to free up the username that's being used or the service account that's being used. So we have kind of end-to-end credential life management for your workloads. To learn more, please visit Aembit.io. Thank you.